right, let's go ahead and continue our review now with some math that you will see on the exam. So let's just start back at the beginning here. Preethal has a 11-point lead now over Quamesis, which looks rather insurmountable, frankly, at the moment. But do it for pride. Do it for pride. Close the gap. Don't lose this bat. Anyway, have some paper out, that paper you've been working on. Have pencil out. And if you want a calculator, that'd be a good thing to have out right now as well, since we will be reviewing some math at this point. All right, so all of you are going to work the problem, even though I'm asking them the question. If neither of them gets it, you only get one guess, quote unquote, one try for the answer. So once you speak, that is your answer. And if neither of them gets it, then we'll go to the next two. If neither of them gets it, we'll just move on with your question. All right, so I have a rectangle. The base of the rectangle is 5 feet. The base of the rectangle is 5 feet. The altitude is 24 inches. What is the area? 10 square feet.
Oh, yeah. Okay.
Remember, make the 24 inches into 2 feet. Or make this 60 inches, in which case you get 1,440 inches squared. Question.
I want the cap to my compass, and it keeps it from sliding off when I go around.
Sure. All right, next two. Actually, let's go to the back row, and then we'll come back to the next two while he gets the whatchamadoogie thing. Let's suppose we have a trapezoid back row. All of you working it, though. We have a trapezoid, and the bases are, let's say, 7 inches and 15 inches. And suppose the altitude is, I don't know, 9 inches. Find the area.
99 inches squared.
99 inches squared, that's correct. All right, middle two. Middle two. We have a square. Each side of the square is 13 yards. Each side of the square is 13 yards. Find the length of the diagonals.
13.
Front row. 13 times the square root of 2. 13 times the square root of 2 yards, because remember, a diagonal in a square makes a 45, 45, 90, where the sides would be the x's and the diagonal would be the x squared of 2. All right, let's come back to the middle again. We have a triangle. The area of the triangle is 68 inches squared. And we know that the altitude is 8 inches. Find the base.
17 inches squared. 17 inches.
17 inches. I'll give you the unit difference. But yeah, 17 inches would be our base. Again, we would say that triangles equal to a half BH, so we take half of the 8 to get 4B. And of course, the 68 would go in here. That's where we get the 17 inches from. Back row, if I have a 37-degree 12-minute, 56-second angle, find the complement. Find the complement.
Uh, 62 degrees, 77 minutes and 34 seconds.
Ooh, that is not correct. Kendall? Front row.
62 degrees, 78 minutes, and 44 seconds.
Do you have something? All right, remember we're going to subtract from 90 degrees. But we can't subtract from nothing. So we're going to borrow a degree, make this 89, which would give you 52 degrees. But that 1 degree becomes how many minutes, class? 60, not 100. 60 minutes. But you can't even subtract that from 60 because we have to borrow again, make this 59 minutes, and that 1 minute becomes 60 seconds. So we should have had 52 degrees, 47 minutes, 4 seconds. All right, front row, you get your own problem. Find the supplement. Find the supplement.
2 degrees, 47 minutes, and 48 seconds.
No, that is not correct. What do you have, Ethan?
Ninety-two degrees, 77 seconds, minutes, and 78 seconds.
That is not correct. Next two.
92, 47, 92, 47, 48.
There we go. 92, 47, 48 would have been the correct answer. Remember, you're subtracting for the supplement from 180 degrees. That's how you were 2 degrees off, right? Or 90 degrees off. 92 degrees. But again, you borrow, make it a 60. Borrow, make it a 59. Make that the 60. So you end up with 179, 59, and 60. 60 minutes in a degree. 60 seconds in a minute, not 90. All right. So quick refresher on that was good. Apparently needed. Let's suppose we have, back row, a right triangle. Right triangle. If the two legs are 35 inches and 12 inches, find the hypotenuse. 35 inches and 12 inches.
210 inches squared.
I did not ask for the area, I asked for the hypotenuse. Let's go to Kendall. That would have been the area, Jamie.
1,369. No.
Front row?
37.
37. You just forgot to take the square root. 37 inches would have been our hypotenuse. Use the Pythagorean theorem to find the hypotenuse. Next two, middle set. If we have two regular nonagons, and there's a side of one nonagon that is 4 inches. There's a side of the other nonagon that is 7 inches. So a side of the first regular nonagon is 4. The side of the other regular nonagon is 7. The area of the first nonagon is 64 inches squared. What is the area of the other nonagon?
112 inches squared.
That is not correct. Give Genesis a chance. And then we're going to the back row, so back row, be ready.
You said that was the area of the first one?
This is the area of the first regular nonagon. Looking for the area of the second. It is 196 inches squared. Remember that regular polygons, if they have the same number of sides, are always going to be similar to each other. So a regular 9-sided figure and any other regular 9-sided polygon are going to be similar. So we could say that area is to area as side squared is to side squared. So we needed to say that 64 is to area prime as 16 is to 49. Needed to square them. And that's where we would have got our answer of 196 inches squared. Back row. We have an equilateral triangle. I know the perimeter of the equilateral triangle is 27. Let's not do that to you. Let's say 30 inches. The perimeter of the equilateral triangle is 30 inches. Find the length of the altitude. Equilateral triangle, perimeter 30. Find the altitude.
5 times the square root of 3.
It is 5 times the square root of 3 inches. All right, remember, if perimeter is 30, each side then is 10, which means each half is 5, and since the altitude is 5 squared of 3, opposite the 60-degree angle, 5 times the square root of 3 inches. Good. Front row. The perimeter of a square is 78 centimeters. The perimeter of a square is 78 centimeters. Find the area.
308.25 centimeters squared.
You know what? That number I made up was not the number I wanted it to be, but your answer may be correct. Say that answer again.
It is correct.
380.25 centimeters squared.
Yes, 380.25 centimeters squared is correct. All right, that was not the number I meant to come up with. All right, but good job handling it just fine anyway.
Let's say that is not divided evenly.
Yeah, you know, starting to go with a rather obscure multiple of 4 and did a horrible job of it. So obscure, it's not even a multiple of 4. All right, next two. It's true. You do lose some, lose some. Next two. We have a right triangle. I know the hypotenuse is 29 meters. The hypotenuse is 29 meters. One leg is 20 meters. Find the area of the triangle. I have a right triangle with hypotenuse 29, leg 20. Find the area.
$42.05. That's way off. Never mind.
21.
Back row?
I was gonna say 21.
It's not 21.
The other leg is 21, but I asked for the area. So we need to take the formula, right triangle's a half leg, and take half of this to get anyone
210.
210 meters squared would have been our area. If I have a trapezoid, back row,
Wait, how'd you do that? I'm sorry.
T sub RT equals a half leg. Use Pythagorean theorem to get the other leg, and then you take the two legs, multiply them, and take half to get the area.
Yeah.
All right, back row. I have a trapezoid. One base is 4 inches. The other base is 18 inches. What's the length of the median? Front row? 11 inches. Remember that in a trapezoid, the median is half the sum of the two bases, which is why trapezoid equals half h times b plus b prime, or trapezoid equals hm, because half the sum of the bases is the median. All right, let's suppose we have a circle. Pretend that's a circle. Suppose we have a diameter here. We'll call the center point O, and we've got some lines here. Let's suppose we call these points A, B, C, and D. And we'll open this up to anyone. So this doesn't have to stay in the row again. We'll just open it up to anyone. But once you hit one, I'll have you sit out the next. Let's suppose I know that arc AC is 130 degrees. And let's suppose I know that arc DC is 110 degrees. I want to find the measure of angle AOB. Excuse me, not A, I'm so sorry. Wow. BC is 130. I'm looking, I was like, wait a second, that's not an A. AC has to be 180, right? Sorry. BC is 130, DC is 110. What's the measure of angle AOB?
20? No, it's How is that 110?
Because it said it was.
60.
It should be 50 degrees. We know that if this is a diameter, because it goes through O, we have 180 degrees, right? 130 of them here, how many degrees does that leave for arc AB? 50 degrees. What kind of angle is angle AOB?
Central.
Central angle is equal to its arc, so it should have been at 50 degrees. For that one, find the measure of angle DCA. Angle DCA.
70.
35. Remember that an inscribed angle is equal to half its arc. So since the arc is 70, the angle must be 35. Find the measure of angle ACB. 25. Because ACB again is an inscribed angle which equals half its arc. Let's suppose we had some parallel lines. I'm going to say, Quentin, you're still out from the last one though.
Am I out?
No, you come back in because you only set out one. All right, so let's suppose we've got some parallel lines. Suppose we've got a transversal here, maybe another transversal here. We're going to call these angles 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. If we're given that M is parallel to N, and I know that angle 1 is 72 degrees, find the measure of angle 8. 72 degrees, because these are corresponding angles. Let's suppose we wanted to find the measure of angle 9. Someone besides Jamie.
68.
You only get one guess here.
108.
108. 108. Because remember, 8 and 9 together are supplementary. All right, Chris, now you're out. Jamie back in. Let's find the measure of angle 5. 72 degrees. Ethan. Vertical angles always equal to each other.
I'm back in.
Yes, Chris back in. Let's suppose we know that angle 3 is, let's just say 40 degrees. Find the measure of angle 4.
So that's 68.
68 degrees, because together these make a straight angle. We've already got 112 degrees, that makes 68 degrees more. Find the measure of angle 7.
72.
40 degrees.
Is 40 degrees. 3 and 7 are alternate interior. If 3 is 40, 7 must be 40 also. All right, and last quick review here. If we have a 30, 60, 90, of course we'll label this side class as X because it's across from the 30, not because it's the bottom. We'll label this side 2X, and we'll label this side across from the 60. If we have equal legs here, we would label the legs as X, and the hypotenuse. If we had 30, 60, 90, we would label this side
As X times the square root of 3.
X times the square root of 3. All right. Questions? All right, if you would go and get your notebooks set out so that I can collect those from you. Quamesis makes valiant effort, gets to 70 points, but Krieftel makes it to 80 points. So 80 to 70, our final score. And congratulations to Krieftel.
What do we get?
An airhead.
No, I'm all out of airheads.
Okay.
Can you pay my book fee?
No.
No, it doesn't.
He thought about it for a second.
No, not paying book fees today.
We don't have to do half
It was
these.
worth a try.
It was worth a try.
We don't have to do
All
half
right,
these.
so notebooks, if you would set those out, and I'll collect them in just a moment.